Bismillahirrahmanirrahim. Today we are going to do exercise 2.3, in which we are going to learn about the relation between the roots and coefficients of a quadratic equation. So over here we know that if I write a quadratic equation in standard form, it will be ax square plus bx plus c is equal to 0. This is the standard form of the quadratic equation, and over here the coefficients are a, b, c, a, b and c. These are the coefficients, and we know that from the quadratic formula we have two roots at the most of a quadratic equation. Those two roots are these. One is with the plus sign, and the other, if I write it separately, will be, this is the first root, this is the second root, minus b minus under root b square minus 4ac over 2a. This is the first root, this is the second root of the quadratic equation, and a, b, c, these are the coefficients. Okay, now we are going to learn about the relation between the roots and coefficients of the quadratic equation. Now let me name the first root as alpha, because that is how we are going to discuss in the exercise in your book. Let me name the first root as alpha and the second root as beta. Okay, so we have a quadratic equation. This is the standard form. Its coefficients are a, b, c. Coefficient means the coefficient of x square, coefficient of x, and the coefficient of x raised to power 0, or the constant term. These are the three coefficients, and these are the two roots. Alpha and beta are the two roots, alpha and beta. Okay, these are the two roots of this quadratic equation, and a, b, c are the coefficient. We want to learn a relation between the roots and coefficients, okay, between these roots and the coefficient of this quadratic equation. For that we will find the sum of quadratic roots, because we know that alpha is written in the form of coefficients of this equation, and over here we also have in beta we also have the coefficient involved in finding the second root and the first root. All we have to do is put the coefficients in the formula and get the root. So there must be an equation. We can easily develop an equation between these two roots by adding and finding the product. So first of all I am going to find the sum of the roots, which will give me an equation between the roots and the coefficient, and then I am going to find the product of the roots, which will give me another equation or relation between the coefficients and the roots. So the first one is to find the sum. If I want to find the sum, I will add these two. So alpha plus beta, which I have named as the roots of the equation, their sum will be minus b plus under root b square minus 4ac over 2a, plus the second root beta is minus b minus under root b square minus 4ac over 2a. Now if I add these two, what will I get? As we have the same number in the LCM, so I can write them in the form of a single denominator. We will have plus under root b square minus 4ac plus minus will be minus b. Okay, over here we have this bracket, as there is a positive sign before this bracket, so the signs in the bracket will remain the same, and we are going to get this expression after opening of this bracket over 2a. This will be cancelled out with this number, and we will be left with negative b will be which will be negative 2b over 2a. cancelling out 2, we will get negative b over a. So it means that if we add the two roots, it is equal to the ratio of the coefficient of x and a, negative of the ratio between this was the coefficient of x and this is the coefficient of x square. So this is one relation between the roots and the coefficient of a quadratic expression. And to get to the other relation, let me note it down here. Alpha plus beta is always equal to negative of coefficient of x over coefficient of a, as we are proving it for the general quadratic equation. So you can apply this relation to any quadratic after it is transformed into its standard form. Now let us find one more relation, and for that I am going to take the product of these two roots. Product of alpha beta or product of the roots, which will give me one more relation between the roots and the coefficients. Alpha into beta will be, alpha will be minus b plus b square minus 4ac over 2a into minus b minus b square minus 4ac over 2a. Here we have a plus b into a minus b. So applying the formula a plus b, for example this is a plus b, okay, and over here we have difference between the same number, so this is the bracket a minus b. So we know that this a plus b into a minus b is always equal to a square minus b square. So I am going to apply this formula, taking negative b as a. This will be equal to a square minus b is b square minus 4ac whole square over 2a into 2a will be 4a square. Okay, so you are applying the formula a square minus b square. This is b and this is a plus b, a minus b. So if I open these brackets, we know that this negative sign will be ignored, because square of a negative number is equal to the square of its positive number, minus cancelling 2 with this root, we are getting b square minus 4ac over 4a square. Opening the bracket, we are going to get b square minus b square plus 4ac over 4a square. Cancelling out these two, we are going to get 4ac over 4a square. Cancelling out 4, and over here we have square of a, and over here we have 1a, so we are going to get c over a. It means the product of the roots is always equal to c, which is the coefficient of the constant term, over a, which is the coefficient of x square. So this is the second equation or the second relation. The first was alpha plus beta is equal to minus b over a, and the second is alpha into beta is equal to c over a. So this is these two equations shows the relation between the roots and the coefficients of a quadratic equation. Now we are going to apply these two equations to solve different question in the exercise 2.3. So till now we have studied these two relations. Alpha plus beta is equal to minus b over a, and alpha into beta is equal to c over a. Now starting with the exercise 2.3, the first question is, without solving, find the sum and the product of the roots of the following quadratic equation. It's so easy. We are just going to use this relation to find the sum and this relation to find the difference of the roots of the given equation. Let me do one or two equations for you. For example, the fifth one, this is a difficult one. Let me do an easy one first, and then we are going to do the fifth one. Okay. First question is question number 1. We have to find, we are given the equation x square minus 5x plus 3 is equal to 0. This is a quadratic equation, and they want us to find the sum and the product of roots of this equation. We know that the sum of the roots is equal to alpha plus beta is equal to negative b over a. Okay, and product of the roots is equal to alpha into beta is equal to c over a. So in this equation we know that a is equal to 1 because a is the coefficient of x square, b was the coefficient of x which is negative 5, and c is the coefficient of 3. So a is 1, b is negative 5, and c is 3. Now they want us to find the sum of the roots. We know that sum of the roots by formula is equal to negative of ratio of the coefficient of x over coefficient of x square. For this equation it will be negative of, what is b? Negative 5, and what is a? 1. So it means that the sum of the roots will be 5. So it means whatever the roots of this equation are, their sum will be equal to 5. Okay, and they want us to find the product also, which is, we know that is equal to c over a. Over here c is 3, the coefficient of x raised to power 0 over a is 1. So this implies that alpha into beta is equal to 3. So this is the product of the roots of this equation, and this is the sum of this the roots of the given equation. This is how you solve question number 1, part 1. Now I am going to solve question number 1, part 5 for you, and then it will be enough for this question. Now part 5 is question number 1. Part 5 is L plus M x square plus M plus N x plus N minus L is equal to 0. This is the equation which is given to you, M plus N x, and yes. Now we want to find the sum and difference of the roots of this equation. Now we know that a is L plus M, M plus N is b because it is the coefficient of x. Coefficient of x square is L plus M, so this whole thing will be a, this whole thing will be b, and this whole bracket will be c. So over here we have a is equal to L plus M. You can also use capital ABC, and b is M plus N, and c is N minus L. Now if you want to find the roots of the equation, it will be alpha plus beta is equal to negative of b over a. Over here b is M plus N and a is L plus M. So it means that alpha plus beta is equal to negative of M plus N over L plus M, and that's it. This is sum of the roots, and the product of the roots will be c over a. C is N minus L over a is L plus M. Okay, so alpha into beta is n minus L over L plus m. So that is what they had asked us to find, the sum of the roots and the product of the roots. By using these two relations, we can find the sum of the roots of any quadratic equation given to us if we know the coefficients, and we can find the product of the roots in the same way if we have the coefficients of the given equation, or if we have the given equation, we can compare it with the standard form of the quadratic, and we can easily find the coefficients. After finding the coefficient using these relations, you can find the sum and product of any the sum and product of the roots of any equation. Now let's move to the next question. Question number 2 is find the value of k. Question number 2, find the value of k if sum of the roots of the equation, this is the equation given to us, and they have given us that the sum of the roots of this equation is twice means 2 times the product of the roots. The second part is sum of the roots of the equation, this is 3/2 times the product of the roots. So I will do the second part for you, and you can do the first part by using the same method as this, except that here twice means 2 times. Okay, we will use 3/2 times here, and here you are going to use 2 times. So I am going to do question number 2, part 2 for you. Find the value of k. We have to find the value of k, and they have given us the condition that the sum of the roots of the equation of this equation, the sum of roots of this equation is equal to 3/2 times the product of the roots. It means alpha plus beta is equal to 3/2 times alpha into beta. Okay, so let me write the equation they have given to us. Question number, this is question number 2, part 2. Over here, the equation that they have given to us is x square plus 3k minus 1x plus 5k is equal to 0. X square plus 3k minus 7x plus 5k is equal to 0. This is the equation given to us, and they are saying that sum of the roots is equal to 3/2 times product of the roots. This is what they have given to us. So let's start the solution. Now sum of the roots is alpha plus beta, okay, and product of the roots is alpha into beta, and we know that sum of the roots is equal to, by using the formula, minus b over a. In this case, let me write ABC first. Over here, a is equal to 1, b is equal to this 3k minus 7, and c is equal to 5. Okay, these are the coefficients. So alpha plus beta will be minus b is 3k minus 7 over a. What is a? A is 1. So it means that alpha plus beta is equal to negative of 3k minus 7, which you can write as 7 minus 3k. After this negative sign is multiplied with this bracket, we get 7 minus 3k. So alpha plus beta is 7 minus 3k. And similarly, if you want to find alpha into beta, this will be c by a. C is 5k. Sorry, c is 5k, not 5, because the constant term as a whole is 5k. This is the coefficient of x raised to power 0. So 5, okay, this is c over 1, so it is equal to 5k. So it means that alpha plus beta is equal to 5k. Now in the given question, they have given us that the sum of the roots is equal to 3/2 times its the product of the root. It means sum of the root, it is given that is equal to 3/2 times the product of the roots, and we have to find k. Okay, so if you want to find k, obviously you need an equation in which k is involved. So what am I going to write is alpha plus beta we know is 7 minus 3k. So I am going to put the value of alpha plus beta from here, and we are going to get 7 minus 3k is equal to 3 by 2 times what is alpha into beta, 5k. Now we have got an equation in k, and we can easily get the value of k by using this equation. In order to get this equation, we have used this condition which was given to us in the question, and in order to use this condition, obviously I had to find alpha plus beta and alpha into beta, so that k is involved, k can be, so that the values of alpha plus beta and alpha beta can be replaced by the expressions involving k. So now multiplying 2 on both the sides, we are going to get this, and 3 into 5k will be 15k, and 2 is shifted to the right hand side, to the left hand side. After this will be 14 minus 6k is equal to 15k. Now shifting 6k to the right hand side, this will be equal to 15k plus 6k. This will be equal to 14 equals to 15 plus 6k will be 21k. So this implies that the value of k will be 14 over 21. Now this is the value of k which they had asked us. Now moving to the next question. Question number 3. Question number 3, part 1 and 2. There are two equations. There are two parts. I will do part 2 for you because they are of the same method. First, let us read the question. Question number 3 is find k. Here also you have to find k, and it is given that the sum of the squares of the roots of the equation, this is 2. And in part 2 it is given that sum of the squares of the roots of the equation, this is 6. I will do part 2 for you. Same method will follow for part 1. So over here we are given the equation x square minus 2kx plus 2k plus 1 is equal. We are given the equation, and they have given us that the sum of the squares of the roots, it means you are squaring the roots and then you are adding it, and the result is 6. Sum of the squares of the roots of the equation, this is 6. Sum of the squares of the roots. Sum means when you add something, you are adding squares of the roots. So if alpha and beta are the roots of this equation, we will suppose alpha and beta to be the roots of this equation. We will square them, we will add them and put it equal to 6. And from those equations, we are going to find the value of k. Okay, so let me write the equation first. Over here the equation is x square minus 2 kx plus 2k plus 1 is equal to 0. Okay, now we have to find the value of k, and we are given that the sum of squares of the root alpha square plus beta square is equal to 6. We are given that the sum of the squares of the roots is equal to 6, and they have asked us to find the value of k. Now the solution is, we know that alpha plus beta can be calculated by using the relation minus b over a. So alpha plus beta for this equation will be, over here let me write the coefficient of these equations. Coefficient, the a will be 1, b will be the coefficient of x which is negative 2k, and c will be the constant term which is 2k plus 1. Now using b and a, alpha plus beta will be negative of, what is b? Negative 2k over a is 1. So alpha plus beta is equal to 2k. Okay, and finding alpha into beta, I am finding these because I will use these to find the value of k after putting their values in this equation. Alpha into beta is c over a, so c is 2k plus 1 over a is 1. So it means that alpha into beta will be 2k plus 1. Now let me name these equation as, let it be 1, let this be 2, and let this be 3. Okay, equation 1 was alpha square plus beta square is equal to 6. This is equation 1 which was given to us in the question. Now what step I am going to do is I am going to square equation 2. Squaring equation 2, what do we get? Alpha plus beta whole square is equal to 2k whole square. Now opening this with the help of a plus b whole square, this will be equal to alpha square plus beta square plus twice of alpha into beta is equal to 4k square. Alpha square plus beta square, we can put its value from 1 is equal to 6. This is equal to 6 plus twice of alpha into beta from this equation is 2k plus 1, which is equal to 4k square. Now we have got an equation in k which can easily be solved because this is a quadratic equation. We can solve it for the values of k. But first let me simplify it. This will be 6 plus 4k plus 2 is equal to 4k square. Shifting all the terms to the right hand side and adding these two, 6 plus 2 will be 8. I will shift it to the right hand side, so it will become negative 8 4a square, and shifting 4a to the 4k to the right hand side, we will get negative 4k, and 6 plus 2 is 8. After adding them, I am going to shift it to the right hand side, which will become negative 8 equals to 0. This is a quadratic equation. Over here we can take 4 common, so this will be k square minus k minus 2 is equal to 0. Dividing both sides by 4, we will get the equation k square minus k minus 2 is equal to 0. So I am going to solve this equation to find the value of k. Now taking this equation, k square minus k minus 2 is equal to 0. In order to find the value of k, I am going to solve this equation by factorization. We can solve it, I think, by factorization. Two numbers whose product is equal to negative 2 and whose sum gives us negative 1 will be 2 minus 1. Negative 2 plus 1, because we need a negative 1 over here, so I am going to put negative sign with the greater number. So here we have negative 2 and 1, its product is negative 2 and their sum is negative 1. So it will be k square minus 2k plus k minus 2 is equal to 0. So taking k common, k minus 2 plus k minus 2 equals to 0. K minus 2, k plus 1 is equal to 0. So either k minus 2 is equal to 0 or k plus 1 is equal to 0. Over here we are getting two possible values for k. So it means that the values of k can be either 2 or minus 1. Okay, it can be any one of it to satisfy the given condition. So we have found the value of k which they had asked us to find, and this completes the solution for this question. Now let's move to the next question. Now in the next question, again we are going to use the same relation, and there are two parts. Find p if the roots of the equation x square minus x plus p square is equal to 0 differ by unity. Unity means 1. Okay, and the second part is the roots of the equation x square plus 3x plus p minus 2 differs by 2. So I am going to do the second part for you. The same method will be followed for the first part in order to solve it. So question number 4, part 2 is that you are given the equation x square plus 3x plus p minus 2 equals to 0, and it is given that this is the equation which is given to you, and they are asking us to find p, the value of p, if the roots of the equation differ by 2. The differ by 2 means the difference between the roots is equal to 2. These are the things which are given to us, not this. The difference between the roots is given and the equation is given, and we have to find p, the p which is involved in the constant term. So let me write the coefficients first. A is equal to 1, b is the coefficient of x which is 3, c is the constant term which is p minus 2, and they are saying that the difference between the roots is equal to 2. It means that alpha minus beta is equal to 2, or you can say that if I take one root as alpha, the other beta, we can find it by shifting beta to this side and 2 to this side. Beta will be alpha minus 2. So it means that over here the two roots are alpha and the other root is beta, which is alpha minus 2. So we have two roots, alpha and alpha minus 2. These are the two roots. Okay, and we have to find the value of p. Now we know that the sum of the roots is equal to alpha plus beta will be 3 by 1. So if I first let me write the product, because it will involve c, and c over here involves p, so we are concentrating on p. So I'm going to write the product, the relation between the product and the coefficients of the quadratic expression, because then we will get p from here. If I need, then I will find the sum of the roots or use this relation. Okay, over here let me try this one. If it is necessary, we will use this equation. Otherwise, if things goes right and we can find p from only this equation, then it will not be this equation will not be used. Okay, now we know that alpha into beta is c over a. C is p minus 2 over a is 1. So it means that alpha into beta for this equation is p minus 2. We know that alpha, the first root is alpha and second beta is alpha minus 2. Okay, the product of the roots is equal to p minus 2. Now as you may see, this equation is not enough to find the value of p. So what am I going to do is I am going to use this equation also. I will find the sum of the roots also. Now sum of the roots is minus b over a. Now we know that the roots are alpha plus beta is, the second root is alpha minus 2 is equal to minus b over a. B is 3 over 1. So it means that alpha plus alpha minus 2 is equal to negative 3. Now from this alpha plus alpha will be twice of alpha, and shifting 2 to the right hand side, negative 3 plus 2 will be negative 1. So over here we have 2 alpha is equal to negative 1. Put a line over here. So this implies that alpha is equal to negative 1 by 2. Okay. Let me name this equation as 1 and this equation as 2. Now what am I going to do is I am going to put the value of alpha from here, which we obtained from this relation. Okay, alpha plus beta, we got the value of alpha as negative 1 by 2 and we have the equation 1 over here. What am I going to do? I am going to put the value of alpha from here into this equation, and this will give me the value of p. Let me write this equation first. Alpha into alpha minus 2 is equal to p minus 2. This was the equation that we got from the product of the roots. Okay, and this is the equation which we got from sum of the roots. Okay, so we have two equation, equation 1 and this is equation 2, and now we can easily find the value of p by putting the value of alpha from equation 2 to equation 1. So we'll get alpha is negative 1 by 2, putting value of alpha we'll get negative 1 by 2, negative 1 by 2 again, putting the value of alpha minus 2 is equal to p minus 2. Over here this will be adding these two because we have two same signs, so these two will be added. This will be negative 1 minus 4 by 2 p minus 2, and negative 1 by 2, this is going to be negative 5 by 2 is equal to p minus 2, and multiplying these two minus plus, this will be 5 over 4 is equal to p minus 2, or p minus 2 is equal to 5 by 4. Shifting 2 to the right hand side, p is equal to 5 by 4 plus 2, so p will be equal to 5 plus 8 by 4, and this is 13 by 4, which is the value of p which we had required. Okay, so this is how you solve this question by just using these two relations. And that's all for today. We'll continue to do the next question in the next lecture, inshallah.